Hello and welcome to all. In this lecture, we are going to discuss how to generate the string by using the given grammar. Before that, we already know that the definition of CFG. CFG is nothing but context-free grammar, which is defined by using four tuple. For example, CFG G is equal to VTPS, where V is nothing but set of variable, T is nothing but set of terminals, P is nothing but set of production, and S is the special or start symbol of the grammar. So variable, V is variable, which is denoted by using capital letter A to Z. T is the terminal, which is denoted by using small letter A to Z or digits 0 to 9. P is the production or equation which are required to generate the string by using the grammar, and S is the starting symbol of the grammar. Now whenever you want to generate the string or derive the string by using the given grammar, there are two ways to generate the string by using the given grammar. So first one is sentential form and second one is the past tense form. So we'll see one by one. First one is sentential form. So directly we'll consider one example, and with the help of that example we'll see how to generate the string by using sentential form. Here consider the following CFG, means context-free grammar G, which having three production P1, P2, P3, where S tends to, or S is equal to A1B, A tends to 0A or A tends to epsilon, B tends to 0B or 1B or epsilon. So these three productions are given. So we know that CFG G, which is defined by using four tuple VTPS. So with the help of above grammar, we can write down all these four tuple. V is equal to variable, which are denoted by using capital letter. So here you can see V is equal to S, A and B. These are the three variables are there. T is nothing but the terminals, and terminals are denoted by using small letter or digit 0 to 9. So here in this grammar, terminals are shown by using the 0 and 1. Now P is the production. So production or equation of the grammar, which is already given. So here P1, P2, P3 are the production of the given grammar or are the equation of the given grammar, and S is the starting symbol of the given grammar. See here, if the starting symbol is D, then we can say that D is the starting symbol, but right now here in this grammar, S is the starting symbol. Now with the help of this above grammar, we want to generate the string 00101. By using above grammar G, generate a string 00101, or we want to check whether this particular string is generated with the help of given grammar or not. So we'll try to generate it 00101. So we want to generate the string 00101. So by using sentential form, we're going to generate the string. See here, now whenever we want to generate the string, we need to always start with start symbol. Whenever we want to generate the string, we need to start with start symbol. So for the given grammar, start symbol is S. So S tends to. So what is the production for S? S having only one production, and that is nothing but A1B. So I'll write S tends to A1B. Now here, let us check the given string. Which string we want to generate? 00101. So we need to replace this A with its production such that it will going to generate this 0. So here for A there are two productions are there, one is 0A and another one is epsilon. If I replace this A with epsilon, then what will happen? If I replace this A with epsilon, then remaining string will be 1B, and actually we want to generate 00, so that will be wrong. So we should replace that A with the 0A. So I am going to replace that A with 0A. So S tends to, so A is replaced with 0A, so that above derivation will become 0A 1B, or our production will become 0A 1B. Here we have just replaced A with 0A and remaining 1B as it is. Now 10 is over. Now next one is again we want 0, and what is the next variable? It will be A. So again I should replace that A with 0A. So it will now I'm going to replace this A with 0A. So 0 is already there. Okay, after that A is replaced with 0A. So now and remaining production is 1B. So now the production will become 00A 1B. Okay, now after that we want the 00 is over, after that we want 1. So which A having two production 0A and epsilon. If I replace again A with 0A, then 30, and after that A is there. Actually we want after 20 we want 1. So we should replace that A with epsilon. Now I am going to replace A with epsilon. So here why A with epsilon? Because A having that production rule. If A having that production rule, then only we can use it. Otherwise we cannot use it. So here S tends to 0 0 and a is replaced with epsilon. So epsilon into anything, we know that that things. So a is replaced with epsilon, so that will be removed and remaining string is 1b. Now 0 0 1 is over. Okay, 0 0 1 is over. First three part is over. Now after that we want 0 0 1. Actually in the production only one variable is left, that is b. So b having three production 0b 1b and epsilon, and actually after one again we want 0. So we should replace that b with 0b. So I will going to replace b with 0b. So it will be 0 0 1, and after that b is replaced with 0b. Now this 0 is over. After that again we want 1, and only one variable is there, b. So again we should replace that b with 1b. So it will going to generate the string as s tends to 0 0 1 0 0 0 1 0, and now b is replaced with 1b. So it will be 1b. Now here you can see 0 0 1 0 1 string is over. So after that what b is still there. So finally all the variable or all the symbols in the derivation of the string should be terminals. So terminals are shown by using small letter or digits, but here one capital letter is there. We should replace it with something, but actually we don't want anything after 1. So we should replace that with its production epsilon. So it will be 0 0 1 0 1, and now b is replaced with epsilon. So as it is possible to generate the string with the help of given grammar, so we can say that this string belongs to the given grammar. So here you can see s tends to, we have used rule 1, rule p1. So this one is rule p1. I'll write all those rules here. S tends to a1b. These are the given rule actually. S tends to a1b. This is p1 rule. After that second rule is what? A tends to 0a or epsilon. This is second rule, which is given. And third rule is what? Third rule is b tends to 0b or 1b or epsilon. So these three rules are given, and we are going to use these three rules to generate the given string. So here you can see, first of all we are going to use this rule a1b. Okay, so s tends to a1b, p1 rule is used. Now that a is replaced with 0a, because we want to generate this 0 0 1 0 1. So a is replaced with 0a, so string will become 0a 1b. So here you can see rule p2 is used, a comma 0a. You should write like this while generating the string. Now after that again we want one more 0. So a is replaced with 0a. So here you can see, okay, p2 again we have used the same rule p2. Again we want 0 0 1. So a is replaced with epsilon. We have used the rule p2 again. Okay. So b and p2 having rule a tends to epsilon. Now b is remain, and b is replaced with 0b. So here you can see b is replaced with 0b, and we have used the p3 production, and p3 having production. Three productions are there. One is 0b, 1b or epsilon. So here we have used b tends to 0b. Now again 0 0 1 0 is over. After that again we want 1. So here we have replaced that b with 1b, because it having production p3 having 1b. So we have used p3 production or rule p3, and b tends to 1b. And after that finally we should replace that b with epsilon, because this string is generated. So rule p3 such that b tends to epsilon is used. Therefore string 0 0 1 0 1 is belongs to the G. This is nothing but sentential form to generate the grammar. Now actually there are two types of sentential form. One is leftmost sentential form, and second one is the rightmost sentential form. So with the help of these two sentential form we can generate the string. Now what do you mean by leftmost sentential form? So leftmost sentential form, in that leftmost variable is picked up for an expansion. Firstly we need to pick the leftmost variable for an expansion of the string or for generate the string. By using above grammar G, generate a string 0 0 1 0 1 by using leftmost. Now we will try to generate the string by using leftmost sentential form. So leftmost sentential form is what? We need to pick, every time we need to pick up leftmost variable to generate to replace the variable. We should pick up the leftmost variable to generate the leftmost sentential form. So here you can see, first every time while generating the string we should start with start variable. So start variable is yes. Okay, again we are going to consider same grammar, that is s tends to a1b, a tends to 0a or epsilon, b tends to 0b or 1b or epsilon. These three we will going to use. Okay. we'll going to use these three. So here, okay, so here also we're going to use these three rules. I'll again write all those rules. So a1b, a tends to 0a or epsilon. So these are the given actually, okay, 0a or epsilon, and b tends to 0b, 1b or epsilon, 0b, 1b or epsilon. So we'll use these three rules to generate the string by using leftmost sentential form. So here, firstly, I am going to use the starting variable symbol rules. So start, because every time while generating grammar, we should consider the starting variable. So s tends to a1b. So now we need to pick up leftmost variable. So from these two, actually only two variables are there in this production, a and b. One is terminal. So terminal that we cannot replace, but a and b are the variable and that we can replace. So a is the variable, and we need to pick up the leftmost variable. So here you can see a is the leftmost, so we need to start generation of string from leftmost variable only. So I have replaced a with 0a, okay, because a having production 0a or epsilon, and we want to generate the 0 0 1 0 1. Same again here also, which one is leftmost variable? A is leftmost variable, so I am going to replace a. Again here also a is leftmost variable, so I am going to replace that a. Now only one variable is left here, and b, and by default that will be the leftmost variable, okay, and I am going to replace b with all the required rules, and finally I am going to generate the string which I want to generate, or which we want to generate with the help of given grammar, okay, and that we have generated by using leftmost sentential form. Now rightmost sentential form. In case of rightmost sentential form, we need to pick rightmost variable first for an expansion, or we need to pick up rightmost variable for an expansion. So now again we try to generate the same string by using same grammar, but by using rightmost sentential form. So again I will write the three rules. S tends to, the given three rules, S tends to a1b. After that a tends to 0a or epsilon, and b tends to, a tends to 0a or epsilon, and b tends to 0b or 1b or epsilon. So these three rules are already given, okay, and we want to generate this string, but now we want to generate it by using the rightmost sentential form. So see here, in case of rightmost also we need to start with start variable, okay. So start variable is what? Yes. So we have used that rule, yes tends to a1b. Now we want to generate string 0 0 1 0 1, but now which one is the rightmost variable? Here b is the rightmost variable. So we need to check by using what we can or by which rule we can replace with b. So b having three rules, 0b, 1b and epsilon, and we want 1, okay. So here 1 is already up, and we want to generate the string 0 0 1 0 1. So finally we want 0 1. So I'll be having 0b or 1b. So what we can do, because here you can see a having only 0a, so these 1 1 are not possible to generate with the help of this a. So that's why we need to generate this 0. So b, I have replaced that, yes, b with 0b. After that again from these two, b is the rightmost, so again I have replaced that b with now 1 0 is old, this part is old, so 1 is remaining. So I have replaced that b with 1b, okay. B is replaced with 1b. Again I need to check the rightmost variable. Here also rightmost variable is b. So and now 1 0 1 is over. Last three variable or symbols are over in the given string, and I need to replace that b with epsilon. Now 1 0 1 is over, but 0 0 is remain, and now there is only one variable is left, that is a. So by default a is the rightmost variable, and I need to replace that a with 0a. So I am going to replace that a with 0a and 1 0 1. Again 1 0 1 is over, but one more 0 is left. So again I will replace that 0 with, a with 0a. So 0 0 a 1 0 1 is there. Now I need to replace that a with epsilon. So it will going to generate the string 0 0 1 0 1. So every time you need to remember, in case of rightmost sentential form, you need to pick up rightmost variable for an expansion, and in case of leftmost sentential form, you need to pick up leftmost variable for an expansion. Now there is one more way to generate the string by using given grammar. That concept is called as parse tree or syntax tree. So parse tree is nothing but set of derivation applied to generate a word can be represented using a tree is called as parse tree, or in simple word, pictorial or graphical representation of the given grammar by means of tree is called as syntax or parse tree. Here pictorial graphical representation of the string is known as syntax tree or parse tree. So whenever we want to draw the parse tree or syntax tree, we need to use three rules. So which tree? Root node of the parse tree means root node of the parse tree is always the start symbol of the given grammar. Interior node of the parse tree, suppose I'll say that root node is of the parse tree starting symbol is yes, so that will be the root node. After that interior symbol, each interior node can be represented with the alpha variable. Each interior node, suppose A1B. So here you can see we have replaced interior node with variable, and each leaf node is represented with the alpha terminals or symbols. So I can replace A with, let us say, 1. 1 is already, this one is terminal, so that will be leaf node, and B is replaced with epsilon, for example. So like this I can generate the string, or like this I can draw the parse tree. Now like sentential form parse tree also having two types of tree. One is leftmost parse tree and second is rightmost parse tree. So in case of leftmost parse tree, I need to replace leftmost variable in the parse tree or left child firstly. Okay, and in case of rightmost parse tree, I need to replace right child firstly with the terminals. So here you can see leftmost parse tree 1001. So how to generate the leftmost parse tree? Okay, for 1001. Suppose yes, I want to use same grammar, and the given grammar is what? S tends to A1B. I'll going to use the same grammar which we have considered. Okay, A1B, A tends to 0A or epsilon, and B tends to 0B, 1B or epsilon. 0B or 1B or epsilon. So, and I want to generate, now I want to generate the string 101, but I want to draw the parse tree. So first of all, as I told you, root node will be the starting symbol. So starting symbol of the given grammar is yes, and yes, there is only one production A1B. So yes tends to A1B. Now we want, after 1 we want 1 is there. Okay, so 1001. So I can replace that A with either 0A or epsilon. But we want 1001. So is it possible to generate the, suppose 1 is there and before that 001 is possible? No, it is not possible. Why it is not possible? Because it does not have production which will generate the 1. So that's why here we have replaced that A with epsilon. Now 1 is already there. Now B is left. Okay. So in case of B, here we have replaced leftmost variable firstly. Okay, in case of parse tree as well. Now 1 is already there. Now B should be replaced with 0B. After that again B is replaced with 0B. After that B is replaced with 1B. Okay, because of this production, and finally B is replaced with epsilon. So here you can see 1001 string is generated or parse tree is generated. In case of rightmost parse tree, we need to pick up rightmost variable firstly. So again the given grammar is yes tends to A1B. So we have used that rules to generate the grammar. Yes tends to A1B. S tends to 0B, okay, B tends to 0B or 1B or epsilon, and A tends to 0A or epsilon. Okay, so here you can see we have used this grammar to generate the rightmost parse tree. So S tends to A1B. Now we need to pick up rightmost variable. So I have replaced that B with 0B. Again I have replaced that B with 0B. Again I have replaced that B with 1B, and finally B is replaced with epsilon. Now one variable is left. Here you can see every time we have pick up rightmost variable, and after that finally we have replaced that A with epsilon, and it will going to generate the string 1001. This is nothing but rightmost parse tree to generate the given string. Thank you. I'll stop here.